Welcome back from spring break. I hope everybody had an awesome spring break and you are well rested and feeling strong to finish the school year out. This is the week of March 29th, and I do want you to have a math notebook out and to take notes while you watch this recording. And we're going to start with a warm-up problem to get our brains thinking back to what we were doing before break, and that was learning how to find the volume and surface area of different three-dimensional shapes. So we're going to start our warm-up with finding the volume of this prism. And remember, this would be called a triangular prism based on the two bases that are triangles. So go ahead and in your math notebook, go ahead and click pause and find the volume of this prism. And when you're ready to check your work with mine, click play. All right, so to find the volume of prisms, we use the formula of volume equals capital B times H. And remember that capital B is the area of the base. That's the area of the base. So in this case, our bases are two triangle. We have two triangle bases. So we want to find the volume of our bases first. So let's go ahead and work on finding that capital B, the volume of our base. So how do we find the area of a triangle? Remember that is 1/2 base times height. And what is the base of our triangle? That would be 8. And the height, remember the height of your triangle must form a 90-degree angle with the base. So that's going to be our height. It's going to be 3 centimeters. It must form that 90-degree angle with the base. So let's go ahead and do the math. 3 times 8 is 24. 24 divided by 2 is 12. So the area of our base is going to be 12 centimeters squared. We don't really need the centimeter squared until the very end. I just wanted to stick it in there, remind you the units for area. And so now we know the capital B is 12. And what is the height of our prism? So remember, the height is going to be the length between, or the length between your two bases. That's the height. It's the length between your two bases. That's the height. So our height is going to be 12 centimeters. So 12 times 12 is 144. If I left my answer for volume as 144, would I get full credit? No, we need units of measurement. Since we're dealing with volume, our units are going to be cubed. And that's it. We found the volume. Base times height. Taking a look at what shape makes up the base, it was a triangle, so we used the area formula for triangles, 1/2 base times height, plugged in the information, and got our volume. So we're going to continue this week to look at volume and surface area. This week we're going to focus on cones, pyramids, and spheres in session 6 and 7. And then we're going to wrap up unit 7 with taking the unit 7 test. Something kind of exciting to take note of is that we only have about 2 months left in the school year. Hard to believe, but it's true. All right, so this week we're going to dive into finding the volume and surface area of cones. That's that shape just like an ice cream cone you would hold in your hand. Pyramids. Pyramids have different bases and then triangle lateral faces that meet at a point, and then spheres just like a basketball. So let's jump right in and look at pyramids. So just like prisms are named based on their bases, the same is true for pyramids. Pyramids are named based on the shape of their base. So we could have the base, if the base is a square, we would call it a square pyramid. Square base, we get that name of a square pyramid. We can have a triangular base, triangle base, which would make it a triangular pyramid. I did want to go over different parts of a pyramid. You're going to have, a pyramid is going to have some type of base. It could be a triangle base, it could be a square base, it could be a polygon base. But all the lateral faces are all going to be triangles. So when we deal with pyramids, all of our lateral faces are going to be triangles. So just keep that in mind. So a lot of formulas we're going to see today involve a slant length and a height. And I wanted to make sure we all understand what each of those are. So slant length a lot of time is going to be represented with an L. A lot of times it's a cursive L. And then height, which is represented with H. And what we need to know is that the height will always form a right angle with the base. So that is what the height is. Make sure you write this down. In your notebook right now so that you know the difference between the H and the L and what a slant length is. So a slant length is the distance measured along the lateral face from the base to the vertex. So that's what a lateral face is. I want to highlight this in a different color here. Let's do this in green. So slant length, we're going to do this in green. So the slant length, again, is the height of the lateral face. It's the height of the lateral face. So again, that slant length, it's a distance along the outside of the pyramid, and it starts at the base, and it's the distance from the base up to the vertex of that pyramid. That's what the slant length is. Where you can see the height is different because it's like if you were to dangle a string from the vertex and it goes through like on the inside of the pyramid and dangles. If you take a string, dangle it down to the vertex, it's going to touch the base in the center there and form that right angle with the base. So you can see that the height and the slant length are different in pyramids. And we're going to use both of those when we find surface area and volume. So let's start with looking at the volume of a pyramid. So the volume of a pyramid is similar to a prism, but a prism doesn't have a point where all the lateral faces come together like a pyramid does. So we're missing part of the prism. Thus, our volume is going to be 1/3 base times height. And again, the B in the capital B is going to be the area of the base. So let's look at an example. Down at the bottom of the slide, we've got a pyramid. We've got a lot of different measurements, and let's find the volume. So I always like to start by just writing down the formula. 1/3 base times height. And let's go ahead and start with finding the base. What's the area of the base? We've got a rectangle. So the rectangle, to find the area of a rectangle, is just base times height. The base of the rectangle is 8. The height is 7. So 8 times 7 is 56. So that's our capital B, the area of the base. So we can plug that into our formula now. Move this over a little bit. So we've got 1/3. We know capital B, the area of our base, is 56. What is the height of our prism? Or I'm sorry, of our pyramid? So remember, the height is if you were to dangle a string from the vertex, dangle it down and it touches the base. That's our height. So the height's going to be 6 inches. So to plug this in your calculator, what I like to do is multiply 56 times 6 first. 56 times 6, and I get 336. And then I like to divide it by 3. So that's one way you can do it. Another way is put it all in parentheses and put 1/3 in parentheses, 56 in parentheses, and 6 in parentheses, and multiply them all together. But I want you to try it in your calculator to make sure you know how to do the multiplication correctly. And you should get 112 inches cubed because we're dealing with volume. So go ahead and make sure that you know how to correctly put that in your calculator and get the same answer that I got, so that when you go to do the assignments, you're good to go. Okay, so moving on. If you do need more time, click pause to write down these notes. All right, surface area. So remember, surface area is all the area on the outside of our object. So with the pyramid, remember, we're always going to have a base, one base that's going to be a certain shape. It can be a square, a rectangle, a triangle, a polygon. So the first thing we would want to do is find the area of our base. So find area of base. And then we're going to add to that, we're going to find the area of all the lateral triangles and add those all together. So that's how we find the surface area of pyramids. So there's two different ways you can do it. You can just go and find the area of the base and then look at each separate lateral face and find the area of each of those triangles and then add them all together. Or you can use this formula. Here's a formula that will help you find the surface area of pyramids. The surface area is capital B. I think we all know what capital B means now. Capital B represents the area of the base. And then we've learned that L represents that slant length. And remember, that slant length is different than the overall height of the pyramid. And then P is going to represent, we've done this before, a perimeter of the base. So this is a formula you can use if you'd rather use a formula rather than finding each separate face area and adding those all up together. We can do both, and we're actually going to try using both methods on the next slide here. But really quick before we do that, remember that lateral face, or I'm sorry, just want to talk about the slant again. Goes from the vertex along the outside of the lateral face down to the base. That's our slant length. Versus the height, which is starting at the vertex going straight down and forming a right angle with the base. We don't use the height length in this formula though. All right, so let's go ahead and try both methods. Let's go ahead and first use our formula to find surface area. So B, we need to find, let's find the B, the area of our base. And this is actually a square. The base has all the side lengths are the same, so it's a square base. So we're going to do base times height, or side times side. That's going to give us 12 times 12, which gives us 144. That's our B, our capital B. Our perimeter, our P, our capital P is the perimeter of the base. So 12 plus 12 plus 12 plus 12 is going to give us 48 as the perimeter of the base. And then we need the slant length. So remember the slant length, which one would it be for the slant length? It's the one that goes along the outside of our triangular lateral face. So it's going to be 10, not 8. So we've got all those identified. Now we can plug those pieces into the formula. Surface area equals capital B plus 1/2 the perimeter of the base times the slant length. We know the capital B is 144 plus 1/2. The perimeter was 48 and our slant length was 10. So let's clean this equation up. First, I'm going to look at the latter part of the equation, that 1/2 48 times 10, and I'm going to do 48 times 10, and I'm going to get 480. Then I'm going to divide that by 2 to get 240. So now we've got 240 plus 144 for our grand total of 384. We're talking about surface area now, so our units are just going to be squared. So I would put units squared since there are no units, but we do want to incorporate that the units are squared. What if now we were to focus on just attacking this by looking at each lateral face and adding those all together? So we're just going to find the area of each lateral face. So let's start with the square. So what's the area? You know what, I want to do this in a totally different color. Let's do the area of a square first. So square would equal, area is equal to base times height. So we're going to have 12 times 12, which is 144. So the area of the square is equal to 144. So I'm going to hold on to that. Now I'm going to do one of my triangular faces, the triangular face area. We know area of a triangle is 1/2 base times height. What's the base of my triangles? Let's go ahead and look at this side. Let's focus on this side triangle over here. So let's find the area of this triangle first. So we know it's a square base, so I know all of my bases are going to be 12. And then what's the height of that triangle? Is it 8 or 12? So we're dealing with the triangle, so we want that slant length of 10 there. So that's going to be, because it makes a right angle with the base of the triangle. So it's going to be 10, the height. So 12 times 10 is 120. Divide that by 2 and we get 60. So the triangle area of that highlighted triangle is 60 units squared. What about if we were to find the area of this front triangle, this one right here? So it also has a base of 12 and a height of 10. So it's all of our lateral faces are going to have the same dimensions, all of our triangles. That's not always true. It just happens to be true in this case because we have a square base. But that's not always going to be true. If you have a rectangular base, you'll find some of your bases of your triangles will have different base lengths. But in this case, they're all the same, so we can go ahead to find the total surface area of all of our triangles then would be equal to 60 times, how many lateral faces are there? There's a front and a back and a left and a right, so there's 4. So if we take 60 times 4, we get 240, and that's going to be the total area of all of our triangles. So then, to find our grand total of the surface area, we would add what we found was 144 to be the surface area of our base, plus, or just the area of our base, plus 240, that's all of our lateral areas. We add that up, we get 384 units squared, which, if you look, that's the same surface area we got with using the surface area formula. So either method works. I just wanted to point that out, that there's more than one method. Whatever makes more sense to you, use that this week. And don't forget that if you want to use the formula, to copy this formula down now. Okay. Ready to move on? If you need more time here, go ahead and click pause, but I am going to move on to the next slide. Cones. The last shape we're going to talk about today is cones. I'm going to leave spheres up for you guys. We are kind of running out of time, so I'm not going to have time to get to spheres, but I will get to cones. Spheres, there's enough information in the slides that you'll be good with that. I think you might even find those formulas a little bit easier for spheres, and that's why I'm going to go over cones with the time that we have remaining. So cones, 2 formulas. Let's talk about the surface area formula for cones. It is pi r s plus pi r squared. So pi r squared represents the area of our circular base, because that's what a cone is. It's got a circular base. And then the pi rs is going to give us that lateral face area, and we'll add those two together. Remember, S is going to equal slant length. It doesn't represent the height, it's the slant length. And the slant length of a cone is very similar to the slant length of a pyramid, where you go from the vertex along the outside of the cone down to the base, and it creates that slant length. So that's slant length. Go ahead and copy down the formula to find, that's to find the surface area. Copy down this formula. We're going to use it on the next slide. And then we've got the formula for volume of a cone down at the bottom. And that is volume equals 1/3 pi r squared times height. So now we're incorporating height. And again, height is if you were to start at the vertex, dangle a string down, and it's going to hit the middle of the circular base and form a right angle with the base. That's what the height is. So go ahead and copy both these formulas down in your math notebook, and then we're going to move on to the next slide and practice using those. So go ahead and click pause if you need more time here, otherwise I'm going to move on. All right, I've got a cone here with some dimensions, and we're going to find the surface area and the volume. Let's go ahead and start with surface area. We need the radius to do the surface area, so what is the radius of our cone? So remember, the radius deals with circles, and it's the distance from the center out to the edge of the circle. That's the radius. We have the diameter is 40, and remember the radius is half of the diameter. So half of 40 would be 20. So our radius is going to be 20. What about the L? What does L represent? It represents the slant length. And what is the slant length of this cone? It is 50 centimeters. So we've got all of our stuff. We can all plug it into the formula now. Surface area will equal pi. Our radius is 20. Our slant length is 50. I'm going to move this down. I'm going to run into the stuff I wrote above. There we go. 50 plus pi. 50 is our, 50 is not the radius. I'm sorry, 50 is our slant length. The radius is 20. Our radius was 20. And then we're going to square that. So let's go ahead and solve in terms of pi. Remember, to solve in terms of pi, that means leave pi in your answer. Don't multiply it by 3.14. So we're just going to leave it in terms of pi. 50 times 20, so 50 times 25 times 10 is 10, and then you get those 3 zeros. Whoops, I went a little too far there. 50 times 10 is 1,000, and then we got to get the pi in there, plus 20 squared is 20 times 20, so that's going to be 400 pi. Both of our terms have pi's in it, so they're like terms, so we can add those together to get 1,400 pi. And that is our surface area in terms of pi. Now let's go ahead and find the volume of the cone. And the volume of the cone, the formula is V equals, there was a mistake in the one that was up there, 1/3 pi r squared times the height. All right, so let's go ahead and identify the radius. We already did that. It's 20. We also need the height. What is the height of the cone? Remember, the height starts at the vertex and goes straight down to the center of the circular base. That's our height. We don't know that. That has not been given to us. Can we find it though? Well, look here. I'm going to highlight half our radius of our circle, our slant length, and our height. What does that create? A right triangle. And we know the radius is going to be that base of the triangle. That's going to be 20 centimeters, half of the diameter is 20 centimeters. So we've got 2 out of our 3 sides of our right triangle, which means we can use the Pythagorean theorem to find the height. A squared plus B squared equals C squared. All right, we don't know our height, so I'm going to put h squared to represent height. The other shorter side is 20, square that. The hypotenuse is our slant length, that's the longest side of 50 squared. Let's keep going with the math. 20 squared is 400, 50 squared is 2,500. Subtract 400 from each side, and we get h squared equals 2,100. To get h all alone, we need to take the square root of both sides. That's the opposite of squaring something, is taking the square root. So h equals, I'm going to go ahead and plug this in my calculator, the square root of 2,100. It's not a perfect square, so I'm going to round to 2 decimal places. I got 45.83. So go ahead and calculate that as well. So we know the height now. It's 45.83 centimeters. Now we're ready to plug everything into the formula. We've got everything we need now to plug it into the formula. I'm going to move the formula over so that I can fit everything in. So we've got volume equals 1/3. We're going to do our answer in terms of pi. Our radius is 20. We're going to go ahead and square that and multiply it by times the height that we just calculated. All right, so I'm going to plug in my calculator. I know 20 squared is 400, so I'm going to do 400 times 45.83. I'm going to get that answer and then divide that by 3, 1/3. So I'm going to do 1/3 pi, and I just found my answer of, when I multiply 20 squared times 45.83, I get 18,332. So I'm going to take that and divide that by 3. So 1,8332 divided by 3. And I'm going to leave pi in my answer because I'm answering in terms of pi. I got 6,110.67 pi. And then because we're dealing with volume, my units would be cubed. So remember, you do need to include units of measurement in your answer to get full credit. And that is the volume of the cone. Surface area, our units will be squared. Volume, your surface area or your units will be cubed. Okay. All right, so that is a wrap. We're ready for the key phrase assignment. I'm actually going to have 2 questions. I'm going to have 2 questions here. You need to answer both questions. You do need to answer both questions. So this is the week of March 29th key phrase assignment. There are 2 questions that you need to answer this week. First, what are the units of measurement for surface area and volume? So surface area and volume do have different units of measurement. What are they? And then last but not least, what does L represent? We talked about a couple formulas today that involved L, and what does L represent? And that's it. So have a wonderful rest of your week. Please reach out for help if you need it. And that's all.